Prove that the terminating decimal d.d1 d2 where the d sub 1 is the 10th digit, d sub 2 would be the 100th digit, and the final one, d sub t, would be the 10 to the minus t digit, has a second decimal representation. We proved that if a real number does not have a terminating decimal representation, then the representation is unique. However, if a number has a terminating decimal representation, then the representation is not unique. There actually is a second representation. The idea is as follows, that if x is equal to, so this is a little scratch work before we start the proof. If x is equal to something that terminates, like 0.74, then x can also be written as 0.739 repeating, 99999, infinitely many times, which is 0.739 bar. Okay, so these look like two different numbers, but in actuality they are the same number. The reason is because the 9 bar forms an infinite series, and so we have two different representations of the same number. So, proof. So let's write down the same idea that we just wrote out. Let x be equal to d dot d1 d2 d sub t minus 1 in the subscript, where t minus 1 is in the subscript. Then the next digit will be d sub t minus 1. And that is permissible because I know that d sub t is greater than 0. And then 9 repeating. Okay, then x is equal to, well, that's the first part, d1, d2 through d sub t. Now then I have a minus 1 over 10 to the tth power. Okay, so this part is the ordinary decimal representation. Minus 1 over 10 to the t, that's this part. And then I have plus 9 over 10 to the t plus 1. Plus 9 over 10 to the t plus 2. And 9 over 10 to the t plus 3, and so on infinitely many times. Okay, so the first part stays the same. And the object is to show that the rest of the terms cancel and give me 0. So minus 1 over 10 to the t. Now the rest of this is a geometric series. The very first term is 9 over 10 to the t plus 1 over 1 minus the common ratio. What's the common ratio? Well, I multiply by 1/10 to go from one term to the next. So the bottom gets multiplied by 10 to the first power. So it's 1 over 10 to the first power is what I multiplied by to go from one term to the next. So that's equal to d point d sub 1 through d sub t minus 1 over 10 to the t power. And then I have plus 9 over 10 to the t plus 1. I'm dividing by 9/10, so that's the same thing as multiplying by 10/9. Okay, and now the cancellation works as we'd hope it works. The 9 cancels the 9, and also 10 to the first cancels the plus 1 in the exponent. Leave me 1 over 10 to the t. And 1 over 10 to the t minus 1 over 10 to the t cancels. And so the proof ends because the next line is going to be exactly what we started with. So these terms cancel completely, and I'm left with d1, d2 through d sub t. So the second representation of x is equal to the terminating decimal d point d1, d2 through d sub t. And that is the end of the proof.